This semester we're going to be doing tons of labs in chemistry. We're going to do at least 20, maybe even 30 different labs throughout the semester. So it's really important that we understand how to accurately use lab equipment and accurately take measurements in a chemistry lab. So every experiment requires that we're both precise and accurate, which sort of sound the same, but there's a minor difference. Precision is how close a set of data points are to one another, and accuracy is how close a set of data points are to the true value. So let's say you're using a piece of lab equipment and you don't really know how to use it for measurement, but you use it the same way every time. Your numbers could be very precise, very close to one another in that data set. However, they would not be accurate because they would not be close to the true value. So it's really important that we can do both of those things, be both precise and accurate. And really, it just requires that you have a knowledge of the appropriate equipment to use and how to use it. So I'm going to go through a couple of different quantities that we'll measure in the lab most frequently, and the first is mass. So mass is the amount of substance that a matter make that, the amount of matter that makes up a substance, and it's measured in grams. Now, typically, we think of an instrument that we use for measuring mass as measuring weight as well. So we use a scale or a balance. However, there is a difference between weight and mass. Um, Mass is the amount of matter that you have, whereas weight is the force due to gravity on that matter. So if you were to go to the moon, you would have a different weight. However, you would have the same mass because you have the same amount of matter. So the scales that we use in the lab actually use the idea of weight because it's the force due to gravity. So gravity pushes an object down onto the top of the scale, and the scale experiences that force. And then what the scale does is because gravity is virtually the same all over the planet, the scale then changes the weight into a mass measurement. Now I have two different kinds of scales in my lab. I've got this, which is a food scale, and this, which is a digital chemistry balance. This is primarily what we will be using in the lab, mainly because of its accuracy of measurement. Um, so it can measure to a hundredth of a decimal point or to a hundredth of a gram. And since in chemistry we're usually dealing with small quantities, it's better to be more accurate and have more of an ability to measure to that hundredth decimal place. Whereas this one here, it measures pounds and ounces, but we'll never use that. And it also measures in grams, but it only measures to the whole number. So it can measure like 12 grams or 13 grams, but it can't measure like 12.4 grams. So in our lab, in chemistry, we will be mainly using this digital balance. Now, another measurement we frequently take is volume, and volume is the amount of space a substance takes up, and you learn in geometry that volume is length times width times height. However, this only can be used when you're measuring certain shaped substances, right? So if you want to measure the volume of a cube, it's very easy to accurately measure length times width times height, but this really isn't a realistic um, thing for stuff that we're going to be measuring in the lab. Not most matter doesn't exist in like these perfect cube shapes. So let's just take a quick look. I kind of want to show you about about the relative size of a centimeter cube, just to give you a little bit more of a visualization. So if you look at this ruler here, this side is the metric side, the other side is inches, so we kind of ignore that. And each one of these numbers represents a centimeter. So 1, 2, 3, 4, 5. And often it confuses people because it says millimeter there, but millimeter is really indicating these small little lines right here. Okay, so if I were to draw like a square centimeter, so let me just do that quick. So here, 1 centimeter by like 1 centimeter. Connect the box. That's 1 square centimeter. So you can see that it's, about the size of like one of my fingernails. Okay. And then if we were to make that cubic, that would be the size of 1 centimeter cubed. Now, we don't often measure in centimeters cubed, okay? We measure volumes of liquids in liters. So just to give you sort of a perception of what the volumes are, A milliliter is 1 centimeter cubed, so about the size of your fingernail cubed, right? That is about 1 milliliter, and we measure the volumes of liquids in liters. Now, there's lots of different glassware and instrumentation that we have in the lab that can hold liquid. We have beakers here, we have flasks, this is an Erlenmeyer flask, and graduated cylinders. Now, if you notice, each one of them has a scale on the side and has a volume measurement. So this is a 400 milliliter, and obviously they aren't to scale. This is a 50 milliliter, this is a 50 milliliter. However, beakers and Erlenmeyer flasks cannot accurately measure the volume of liquid. Now they have a scale on them, so if if you measure out 200 milliliters of something, you have a big enough beaker. If you were going to pour it in there, it could hold it without overflowing. But we never use those two to measure volume. We use a graduated cylinder to accurately measure the volume of a liquid. So it's important that we understand how to read a graduated cylinder. Graduated cylinders, or glass graduated cylinders in particular, some liquids are attracted to the sides and they form something called a meniscus, which is this little bowl shaped thing here. And when we read a graduated cylinder, we read from the bottom of the meniscus. So we would look from the side and see the bottom of the bowl is here. So you have, like 6.3 approximately milliliters of liquid here in the graduated cylinder. So just keep that in mind. And that's in particular for graduated cylinders. We also have plastic ones that don't do this. All right, now let's say we wanted to measure a substance, a solid that is in a regular shape. Well, how can we do that if we can't measure like length times width times volume? Well, we can do this by using a graduated cylinder as well. So if we put a specific amount of liquid, typically water, into a graduated cylinder, and then we placed a solid object into that graduated cylinder, the solid object would displace the water. Okay, so it would increase the volume that is being measured in here. Now that change in volume right here would be equivalent to the volume of the solid. So just by looking at how much water it displaces, we can determine the volume of an irregularly shaped solid. So those are a bunch of different ways to measure volumes based on what what we're trying to actually measure, what substance we have. And last thing I just want to talk about quickly is temperature. So in chemistry, we most often measure temperature in Celsius, and I do have some of these like old school alcohol thermometers. They're a little bit more difficult to read. They're not as accurate. You can get within about a degree of temperature. However, I also have LabQuest that we'll use from time to time when we have to have a more accurate measurement. The LabQuest can go to the hundredths or the tenth place, I believe, in measuring the temperature probe, and it reads a digital scale, so there's no subjective or like reader error when it comes to using the LabQuest. So just based on what experiment we're doing and how accurate our temperature measurement has to be, we'll be using either the alcohol thermometers or the LabQuest temperature probes. So hopefully now you have a better understanding of the equipment we have in the lab and how to accurately use it to measure different quantities.